Today I will talk about Monte Carlo simulation. This is part of my series of lectures on simulation techniques and it is part of business analytics. This is my lecture outline. First I will give introduction, then I'll talk about steps of Monte Carlo simulation, then I'll talk about limitations of Monte Carlo simulation, then I will give you an example in Python code. So Monte Carlo simulation technique was first developed by scientists working on the Manhattan Project during World War II to simulate nuclear reactions. The name Monte Carlo comes from the famous casino city in Monaco, where gambling games rely heavily on chance and randomness, that is, probabilities. Monte Carlo simulation is a probabilistic simulation. It is also known as multiple probability simulation. In Monte Carlo simulation, there is often use of computers. It is about using a random sampling to obtain a range of probable outcomes for the business scenario. Monte Carlo focuses on constantly repeating random sampling. It can be applied to any problem involving formulae or equations. Monte Carlo simulation is, however, not very efficient. Then steps of Monte Carlo simulation. First of all, we make probability distribution. Then we make cumulative probability distribution. Then we generate random numbers. Then we feed information into the model. That is, we define the starting conditions for simulation and we specify the number of runs. Then we collect and evaluate the statistics. So we observe input data in real life situation. Then we fit the input data to theoretical distribution, or we can use actual probabilities derived from input data. Then we generate input data to derive simulation. So these are the steps. First of all, we have observed frequency. We convert frequencies to probability. Then we calculate cumulative probability. Then we generate random numbers and thereby we make statistical distribution of the input data. Limitations: it is computationally intensive and assumption sensitive. It has a limited precision. The models may be at times very complex and there is data requirement because we need to know the input data or at least the statistical distribution of input data. Now let us see an Python example. So let us predict a profit. So net profit is equal to sales volume multiplied by sales price minus unit cost and minus fixed cost. So in the slow market scenario, let us say that we expect to sell 50,000 units at an average selling price of $11. In the OK market scenario, we expect to sell 75,000 units with a price of $10 per unit. In a hot market scenario, we expect to sell 1 lakh units with a price of 8 per unit. Firm production manager advised that unit cost may be anywhere between 5.5 to 7.5 and the most likely cost is 6.5 and the fixed cost incurred is 1,20,000. This example I have taken from internet. So first of all, we import the plotting package. Then we import NumPy. Then we define a market scenario where we define hot market, OK market, and slow market. And the output is the market condition, sales volume depending on these three market conditions, and unit price depending on these three market conditions. Then we define unit cost, and unit cost we use random normal function of NumPy. Then profit is defined as this equation. And this is simulation. So we define number of simulations as 10,000. And this is the code for simulation. And this is the result of our simulation. So this is the graph, and this is in numbers. So probability of loss is 9.92 in our business scenario, and minimum profit is this, maximum is this, and average profit is in positive figures. So this is all for today. Thank you very much.